Welcome to this video. Today we'll be doing Chapter 4 Trigonometry, Section 4.4 Compound Angle Formulas. A compound angle is an algebraic sum of two or more angles. We use trigonometric identities to identify compound angles through trigonometric functions. The sum and difference of functions in trigonometry can be solved using the compound angle formulas. Key concepts. You can develop compound angle formulas using algebra and the unit circle, and you can also apply compound angle formulas to determine exact trigonometric ratios for angles that can be expressed as sums and differences of special angles. So, we've been talking about compound angle formulas, yada yada yada. What are the compound angle formulas? So, for sine, we have sine x plus y equals to sine x cos y plus cos x sine y. And we also have sine x minus y equals to sine x cos y minus cos x sine y. For cos, we have cos x plus y equals to cos x cos y minus sine x sine y. And we have cos x minus y equals to cos x cos y plus sine x sine y. To help us understand this concept further, we can do a question. This question states, use an appropriate compound angle formula to express as a single trigonometric formula, and then determine an exact value for each. So the equation here is sine pi over 4 plus cos pi over 12 plus cos pi over 4 plus sine pi over 12. So just by looking at this, I can tell that my x and y values, I can already tell what my x and y values are just by looking. So the original equation is sine x plus y equals to sine x cos y plus cos x sine y. So let's just focus here for now. Our x value here is pi over 4, and our y value is pi over 12. Like we said over here, our x value is pi over 4, and our y value is pi over 12. This is the original base equation because it has a plus. There's a plus on both sides, here and here. So to solve this, we can just simply plug in our x and y values into either side of the equation and just solve from there. So to make things easier, I use this side of the equation. So we just plug in pi over 4 into our x values and pi over 12 into our y value. So here, we can't add these together because they have different denominators. So we can just multiply this side by 3 to give us pi over 12, 4 pi over 12, like so. 3 pi over 12, sorry. So 3 pi over 12 plus pi over 12 gives us 4 pi over 12. To simplify this, we can just multiply it by 4, divide it by 4, and it will give us sine pi over 3. Our answer, sine pi over 3, can also be converted into a degree format. So sine pi over 3 also equals to sine 60 degrees, which also equals to root 3 over 2. How do I know this? We can simply refer back to our special triangles in grade 11. The triangles are right angle triangles, and each side is different. Each side has a different value. One of the values is pi, for one of the triangles is root 3 over 2. Another question to help us understand this is apply a compound angle formula and then determine an exact value for each. So for here, we have cos pi over 3 minus pi over 4. Looking at this, we can easily say, after doing the last question, that this is our x value and this is our y value. Like I said, pi over 3 is our x value and pi over 4 is our y value. This is the original base equation. I can tell because this is a y, we have a minus here and we have a plus here. But from that equation, it's only showing us this. So this one's a minus and that one's also minus. So just plug in, just like we did earlier, just plug in the x and y values into the equation and solve from there. So our x value is pi over 3, our y value is pi over 4, plug that into the equation. And then since we can't add these together or minus them together right from right here, we can just multiply this by 4 to give us 12, and multiply this by 3 to also give us 12. So that gives us 4 pi minus 12. 4 pi minus 12, 4 pi minus 12, 4 pi divided over 12 minus 3 pi over 12. Subtract them and we get cos pi over 12, and that is our answer.